Yeah. Happy morning, dear friends. Here's yours, Dr. Rajanta. Welcome to Demystify with Ajay. Dear friends, we saw in the previous session that while approaching a supervised learning problem, we divided the labeled data set into two components, namely training data set and validation, that is testing. So rather than relying on a static part of the data for learning the model and using other static part for validation, it is a good idea to come with a rotation of training and testing part to be able to determine how well will the model generalize to an independent data set. Dear friends, in machine learning, generalization usually refers to the ability of an algorithm to be effective across various inputs. And it means that ML model does not encounter performance degradation on the new input from the same distribution of the training data. So for human being, generalization is the most natural thing possibly. We can classify on the fly. So for an example, we would definitely recognize an animal, whether it is a dog or a cat, and even if we don't see its don't see its breed before or anything. Okay, so nevertheless, it might be quite a challenge for a machine learning model. So that's why checking the algorithm's ability to generalize is an important task that requires a lot of attention when building the model. To do that, we use cross validation. And of course, dear friends, we are going to have, in this session, we are just going to see what is this cross validation and what is the purpose of its use and techniques. And there are so many different techniques or there under this cross validation. We are just going to see about hold out. The first one, hold out. Let me just go for k-fold, and next we just go for leave one out, and next it is leave p out. Next, we are just going for stratified k-fold, and of course a few more repeated k-fold is there, and next it is nested k-fold. Okay, so yes, all the other things are there. Yes, dear friends, let me just see one by one. So first of all, what is this cross validation? See, actually, cross validation technique is a cross validation. It is exactly a technique for evaluating a machine learning model and testing its performance. A CV is commonly used in applied machine learning tasks. So it helps to compare and select an appropriate model for the specific predictive modeling problem. And here this cross validation is easy to understand, easy to implement, and it tends to have a lower bias than other model used to count the model efficiency score. All this makes cross validation a powerful tool for selecting the best model for the specific task. Okay, as I have already specified, there are lots of different techniques that might be used to cross validate a model. Still, all of them have a similar algorithm. Yes, of course. The first one, of course, you are going to divide it into a true part, that is training data and testing data. This is common to everyone. And of course, you have to train the training data. You have to test the model onto the training data, and you have to validate the test data. Last but not least, of course, you have to repeat this 3-step a couple of times. So this number depends on the cross validation method that you are using. Okay, as you may know, there are plenty of cross validation techniques. Some of them are commonly used. Others work only in the theory. So let's see this cross validation methods that will be covered in this session. Here it is, of course, hold out, k-fold, leave one out, leave p out, stratified k-fold, repeated k-fold, and nested k-fold. Of course, time series is also there, but let me just take that in time series exact thing. Okay, so here I just specify, repeat it. Okay, now let me just go for the first one, hold out cross validation. Dear friend, it is the simplest and most common techniques. You might not have known that it is a hold out method, but you certainly use it every day. Here the algorithm of hold out technique, that is actually, see, the same divided into training data and testing data. Usually 80% of the data set goes to the training set and 20% of the tested data, that is 20% to the set testing data. But you may choose any splitting that suits you better. Next, as I have already specified, the second one, it is to train the training data, and of course next it is validate the test data. Last but not least, save the result. Okay, so let me just use the hold out method on a large data set, as it requires training the model only once. Okay, it is really easy to implement a hold out. Okay, so let me just for an example, so this is what we are just going to discuss it today. And yes, here we have this hold out cross method. And dear friends, when on just making use of this, in this sklearn matrix, okay, the sklearn, this model selection, we are just importing this train test split. And kindly just observe, dear friend, we are just using a normal numpy array to just create it. And here we are just letting execute it. So yes, we have just executed. That is nothing much I have just done here. To show one important concept when coming towards this holdout. It has a major disadvantages. See, for example, a data set that is not completely even distribution wise. If we may end up in a rough spot after the split. For an example, the training set will not represent this test set. Both the training and the test sets may differ a lot. One of them might be easier or harder. So, moreover, the fact that we test over this model only once might be a bottleneck for this method. So, due to the reason mentioned here, okay, the result obtained by the holdout techniques may be considered inaccurate. That's it. Okay. Yes. Let me just move on to the next one. It is k-fold. Okay. So yes, I'm just going to specify k-fold cross validation. And dear friends, of course, this k-fold cross validation is a technique that minimizes the disadvantages what we just specified in the holdout method. So k-fold introduce a new way for splitting the data set, which helps to overcome the test only once. That is the bottleneck. Okay, and as I have already specified, now in this k-fold, we have to pick a number of fold, that is k. And here usually it would be as like 5, 10, but you can choose any number which is less than the data set's length. And next one, of course, split the data set into k equal parts. Okay, k equal parts if possible. Okay, so they are called the k-fold. Okay, and next one, yes, choose k minus 1 fold as the training data. The remaining fold, it just goes for test data. So train the model on the training data set. Once the iteration of this cross validation, Okay, you must train a new model independently of the model trained on the previous iteration. So here we just start with the iteration. And next it is all about validation. And yes, dear friend, when coming towards this, yes, save this result of validation. And next, of course, repeat this 3 to 6. Okay, 3 to 6 k times. That is the main thing. Each time use the remaining fold as the test set. In the end, you should have validated the model on every fold that you have. And last, of course, it is the one to get the final score, average the result. Average the results that you got here once after saving every results. Okay, yes, let me just perform this in the code and let I just execute it. So kindly just observe, dear friends, this is what the k fold. So each and every iteration it just move on one by one and till it finishes. And here the k it is 5. Okay, so we just have the k times and remaining everything are all towards the test. Okay, so that is what here we just used, and let me just have a validating. And of course, dear friend, kindly just observe the SK model. Here we just imported this k-fold cross validation, and just a simple two array we have just created for X and Y. Of course, we just got two futures with four records, and each 4 records here we just have the labels. And of course, in general, it is always better to use k-fold techniques instead of fold out. And in a head-to-head comparison, k-fold gives a more stable and trustworthy result, since training and testing is performed on several different parts of dataset. Okay, so let I just execute this and kindly just observe. So here, this is what the training data, and remaining it just goes for test. And for the next one, here it is the training data, and here it goes for the test. Okay, and dear friends, we can make the overall score even more robust if we increase the number of folds to test the model on many different sub data set. And still, k-fold method has a disadvantages. So increasing this k result in training more models, and the training process might be really expensive and time consuming. Okay, fine. Now let me move on to the next one. I just go. This is leave one out cross validation. Dear friend, this exact one, leave one out cross validation, which we just shortly specify as like LOOCV, okay, is the extreme case of k-fold cross validation. And imagine if k is equal to n, where n is the number of samples in data set. If k is equal to n, such k-fold case is equivalent to this leave one out technique. Okay, so let I just let you know what is the algorithm. Of course, here choose one sample from the data set, which will be the test set. Of course, kindly just say. And next one, remaining n-1 sample will be the training. And train the model on the training data set. So we are going to train the model, and on each iteration a new model would be trained. So here this one comes towards the iteration. That's it. And next one, validate, and next one, save the result. And what's next? Of course, here repeat 1 to 5. Repeat 1 to 5 n times. That is what the main thing, n times. Okay, so different training and test data you just get, and excuse me. And to get the final score, of course, you have to sorry, it is 7th one. Yes. For getting the final score, yes, you have to average the result that you got it here in this saving. Okay. So yes, let me just make use of this and kindly just observe. This is what? Live one out cross. So we have to specify the n. And dear friends, kindly just observe this LOOCV Skylearns also has a built-in method. Okay, for this there is a separate built-in method is there. Yes, live one out. Okay, and under model selection, and kindly observe here, dear friends, we are having 2 columns, that is 2 futures and 2 records. Only simple things we are just making it. Okay, so the greatest advantage here I just want to specify is, yes, it in this validation is that it does not waste much data. We use only one sample from the whole data set as a test data. So whereas the rest is the training data set. But when compared with this, previously we have just specified now that k-fold or leave one out, this k-fold CV and towards the normal folder. This LOOCV, that is leave one out cross validation, requires building n model instead of k model. Kindly just observe that. And when we know that n, which stands for the number of samples in the data set, it is much higher than k. So it means this live one out is more computational expensive than k-fold. So it may take plenty of time to cross validate the most this model using this. Let I just execute this one. Okay, so if as here I am just made only a simple data set. If the training is 1 and of course testing is 0. If training is 0, of course test is 1. Simple data I just have cleared it. But anyhow, dear friends, as being one among the scientists, data scientists, this rule, it has a general rule based on an empirical evidence, and different researchers suggest that 5 or 10-fold cross validation should be preferred over this live one out. Okay, so here kindly just make it, it is 5 or 10-fold. Got it? Okay, now let me just move on to the next one. Live P out cross validation. And yes, dear friends, this live P out cross validation is similar to the same live one out cross validation, as it creates all the possible training and test data by using P sample. And of course, dear friends, here this P sample, it would be the test set. Okay, fine. Now let me just whatever we specified in the LOOC, yes, is true, and for the same thing here, still it is worthy mentioning it. Unlike this LOOC and k-fold test, let me just overlap something. If P is higher than 1, okay, what happens? Okay, now here let I just go with the algorithm. The first one, of course, as I have already said, choose P sample from the data set which will be our test data. Okay, and the next one, remaining n minus P would be training data. Okay, and next one, of course, dear friend, train the model by using the training data set on each iteration. I just specify each iteration a new model must be trained. And next it is all about validate it, and of course you have to save the model or save the result. And coming towards the main thing, yes, repeat this 2 to 5. Repeat 2 to 5. Here I have to specify according to this cross validation with the P n times. This is very much important. this cross validation with p sample for n times, and yes, to get the final score, average the result which you just got it in the 5, result of 5. Okay, so you have to average it. Okay, so let me just perform it in the coding. So here we just go. Okay, so see here. So yes, dear friend. So this is what whenever you just take this n p sample and towards the n times here, and each and every time it kindly observe this. Even this iteration 3, it happens of this 2 times. So wherever can be this validated data, or it is been first everything in the starting, or everything in the end, or it can be 2 splits. So it is that is what it is specified as like a p sample. And of course, dear friends, there you can just perform this leave p out cross validation using this sklearn, and of course we have a built-in functionality. And to the same array I have just created for this leave p out, and yes, let I just execute it. Nothing much here, but one simple thing is observe what is the training and what is the testing. So here it is 2 3, training is 1 3, training is 1 2, training 0 3, 0 2, 0 1. Yes, you can keep on iteration. Okay, so this is how. And of course, dear friend, this leave p out has all the disadvantages of the leave one out, but nevertheless it is robust as leave one out. Okay, yes. Let me just move on to the next one. It is a good thing, that is stratified. Okay, k-fold. And sometimes we may face a large imbalance of target value in the dataset. For an example, in a dataset concerning wristwatch price, there might be a large number of wristwatch having a high price. In the case of classification, in cats and dogs dataset, there might be a large shift towards the dog class. So here this stratified k-fold is a variation of standard k-fold technique, which is designed to be an effective in such cases of target imbalance. Kindly just have it, right? Target imbalance. Okay, now it works as follows. Let I just specify one by one. And dear friend, here stratified k-fold splits the dataset on k-fold 1. Okay, so such that each fold contains approximately the same percentages of samples of each target classes and the complete set. So in case of regression, stratified k-fold makes sure that the mean target value is approximately equal to all the folds. So both the manner I have just specified, if it is of a classification and a regression. Okay, let me just see the algorithm. Yes, first of all, let me pick a number for this k-fold. Okay, the value for k, and next one, split k-fold data. Okay, data, each fold must contain approximately the same percentage of sample. Kindly just observe this, same percentage of sample of each target class as a complete set. And next one, choose this k minus fold, which will be the training set, and remaining it is a testing. Okay, we all just known, and here of course train the training set. On each iteration a new model must be trained, and towards the thing validate, and here the sixth step, it comes the save the result. And what next? Of course, repeat 3 to 6. Okay, repeat 3 to 6 k times. That is the important. Each time use the remaining k fold on the test side, And in the end, you should have validated the model on every fold that you have. Kindly observe this one. And last but not least, yeah, the final score, what would have? Average of the result, you just got it in the step 6. Dear friend, one thing when you just observe this algorithm, of course, you may have noticed one thing, that is the algorithm of stratified k-fold is similar to be the standard k-fold, but you no need to code something accordingly, as the method will do everything necessary for you. Okay, fine. Let I just specify here, and of course, yeah, here also we have an stratified k-fold built-in function, and all mentioned above as in k-fold is true for this stratified k-fold techniques. When choosing between the different CV model, make sure you are using proper one. For an example, you might think that your model performs badly simply because you are using k-fold to validate the model, which was trained on the data set with class imbalance. And dear friends, to avoid that, you should always do a proper exploratory data analysis on your data. Okay, so kindly just be aware of it. What we just had seen in this k-fold, the same thing here also we just appear it. Okay, next going on towards this repeated k-fold. Repeated k-fold, of course, here one thing I just want to specify, how the number of times you have to repeat this. Okay, so let me just see about the algorithm and come back here. Okay, so yes, repeated k-fold. Okay, yes dear friends, repeated k-fold, or you can just say repeated random subsampling is probably the most robust of all cross-validation techniques in this session. And yeah, it is a variation of k-fold, but in the case of repeated k-fold, k is not the number of folds. Kindly just observe, it is the number of times we will train the model. Okay, so this one, it is mainly important, and general idea is that on every iteration we will randomly select sample all over the data set as our test data. And for an example, if we decide something as like 20% of the data set would be an test set, so 20% will be randomly selected and the rest 80% will become the training data. Got it? Okay, now let me just go for the algorithm. So here k number for number of times. Kindly just observe. Number of times the model will be trained. And the next one, pick a number for sample, which will be the test size. Test set either side. And next one, split the data. Now next, train the training data. On each iteration of cross validation, a new model must be trained. Okay, next it is validate, and of course save the result. Simple na? Yes, of course. And here to be the thing 3 to 6. Yeah, this is what you have to repeat 3 to 6 k times, which we have already specified. Okay, and yeah, to be the final score, you have to take the average of the result from the step 6. Dear friend, here I just want to specify one thing. This repeated k-fold has clear advantages over standard k-fold. Firstly, the proportion of this train and test split is not dependent on the number of iteration. Secondly, we can even set unique proportion for every iteration. Thirdly, random selection of the sample from the dataset makes repeated k-fold even more robust to selection bias. Still some disadvantages it have, that is k-fold CV guarantees that the model will be tested on all the sample, where repeated of course is based on randomized. Okay, so which means that some sample may never be selected to be in the test set at all. Okay, or at the same time some sample might be selected multiple times, so thus making it a bad choice for imbalanced data set. And yes, of course, sklearn will help you to implement this repeated. Okay, so just we call it, and you must set the number of folds here, and of course number of folds that you want to have as like n split, and the number of times the split will be performed, that is n repeats. Okay, and it guarantees that you will have different folds on each iteration. Okay, let I execute. Okay, so yes. So here we just have the exact output. Dear friends, just to show what would be this training set and testing set, that is what here I have just displayed it. But yes, when you just apply this model towards the main functionality, there you can just see the difference. Okay, you can just observe it. Okay, now next one, of course, I just want to specify the important, that is nested k-fold. See, unlike other cross-validation techniques which are designed to evaluate the quality of an algorithm, this nested k-fold is used to train a model which hyperparameter also needed to be optimized. So it estimates the generalization error of the underlying model and its parameter, that is hyperparameter search. And here I just want to make you an elaborated algorithm. First of all, define the hyperparameter combination. And here, see, for current model, if the model has no hyperparameter, C would be empty. Okay, if no hyperparameter, kindly just observe this one. And second one, divide the data, that is into k-fold. Okay, with approximately equal distribution of cases and control. Now next, the main important, let I just take this as my outer loop, because some inner loops is also there. Here, this outer loop, I just for k-fold, k numbers I have to choose, and kindly just see here, in this, set the k as a test data. And perform automated future selection. Okay, automated future selection on remaining k minus 1 folds. And here, kindly make the combination with parameter C, make the inner loop functionality. I just make it. This is inner loop. And inner loop, for this combination of C, perform the K and K minus 1 folds. This is what. Okay. And here again towards this, set the K fold for validation. And here train remaining K minus 2 folds towards the evaluate the K fold. Now coming out of this inner, I just go with this one, that is calculate average of k minus 2. And next, coming towards the outer loop, train the model on k minus 1 fold using hyperparameter. That is combination that yield best average performance overall steps of the inner. Okay, and evaluate model performance on the k fold. Last but not least, the fourth one, calculate average performance over k-fold. Dear friend, this exact inner loop performs cross-validation to identify the best future and model hyperparameter using the k+1 data fold available at each iteration of that outer loop. The model is trained once for each outer loop steps and evaluated on the held out data fold. This process yields k evaluation of the model performance, one for each data fold, and allows the model to be tested on every sample. It is to be noted that this technique is computationally expensive because plenty of model is trained and evaluated. Unfortunately, there is no built-in method in sklearn that would perform this nested k-fold. We have to create a function. So as specified, yes, there is no built-in method in sklearn that would perform this nested k-fold. And yes, here of course you can either implement it by yourself, or here I have just given you a small example of the program. And dear friends, actually here what we just done, yeah, using this we have an evaluator done on an random forest classifier using this nested fold, okay, nested cross validation on a synthetic classification data set. And dear friends, actually note here I just want to specify, consider something as like in running the example a few times and compare the average outcome. So you can use the example on a straight point, okay, starting point, and here adapt it to evaluate different algorithm hyperparameter or different algorithm or different data set, okay. Each iteration, okay, kindly just observe number n estimated here as it is in random, and here it is n estimator, and here it is specified as like an max future, and one main thing it is specified towards this n split as 3. Yes, here each iteration of this outer cross-validation procedure reports that the estimated performance of the best performing model. Here we are using threefold cross-validation, and here the hyperparameter found to be perform the best, and as well as the accuracy hold out the data set. And this is actually an insightful, as we can see. Let I execute this, okay. So yes, we can see that actual and estimated accuracy once again are different, okay. So we can see that coming here. Yes, of course, here both are different, but in this case similar. It is not similar, it is different only. We can also see the different hyperparameter are found on each iterator, showing that yes, here estimated it is 500, showing that the good hyperparameter on this data set and dependent on the specific of this data set. And different, of course, as I have already specified, a simpler way that we can perform the same procedure is by using the cross-val score function that will execute the outer that is loop, outer cross-validation procedure, and this can be performed on a configured grid search. I have specified it. Okay, so grid search CV directly that would automatically use the refit best performing model on the test set of this outer loop. And yeah, this greatly reduces the amount of code required to perform the nested cross validation. And yes, dear friend, actually we have discussed this different types of cross validation in machine learning. Of course, one important thing, as I have already specified, a time series also. There is a cross validation for which we just have mainly two ways. One is related to rolling cross validation, and blocked cross validation is there. But now we are not just going to include it in this, okay? And taking towards this, when is a cross validation is a right choice. Of course, dear friends, I have to specify one thing. Although doing cross-validation of your training model can never be termed as a bad choice. There are certain scenario in which cross-validation becomes an absolutely necessary. Let I just give you the outcome. One second, dear friends. Okay, so when this cross-validation would be a good choice? Once if it is a limited data set. See, actually, let's say if we have 100 data points and we are dealing with a multi-class classification problem with 10 classes. So here 100 data points with 10 classes. Of course, this average out of 10 example per class. So in a 80-20 train test split, this number would go down even further to 8 sample per class for training. So the smart thing is to do here, would be use cross validation and utilize our entire data set for training as well as testing. That can be. Okay, next, dependent on towards the data point. When we perform a random train test split of our data, we assume that our example are independent. It means that knowing some instant will not help us understand other instant. However, that's not always the case, and in such situation, it's important that our model gets familiar with the entire data set which is possible with cross-validation. And next one, it is mainly actually, of course, cons of single metrics. See, in absence of this cross-validation, we only get a single value of accuracy or precision or recall, which could be an outcome of chances. When we train multiple models, we eliminate such possibilities and get a metric per model, which results in robust insight. And next, it is all about hyper tuning. See, although there are many methods to tune hyperparameter of your model, such as grid search is there, Bayesian optimization is there. Okay, so this exercise cannot be done on training or testing data, and the need of a validation set arises. So thus we fall back to the same splitting problem that we have discussed here, and cross validations can help us out on this. Okay, yes, dear friends, I think so we have discussed an important aspect of this cross validation. So if you found this video helpful, don't forget to hit the like button and kindly subscribe to the channel and then view it so that you don't miss any of my upcoming content. And of course, kindly turn on the notification and drop a comment below if you have any suggestions or any questions for future topics. Also you can just specify it, and always specifying, keep learning and stay curious. See you in next video, dear friends. Happy learning.